Okay, so we've already started talking about vertical asymptotes a little bit. This idea that we're going to start talking about in this lesson is also something that will come up in calculus. It's basically using limits to talk about vertical asymptotes. So let f of x equal g of x over h of x. Let that be a simplified rational function with no common factors. The graph of f has vertical asymptotes at the zeros of the denominator. You guys have to know this. So we have a graph. Should look familiar because we did a graph like this in the last lesson. Okay, so if I give you guys this graph, I'm gonna ask you guys a couple questions. First question is, what are the vertical asymptotes? So an easy way to tell, guys, is look at the curves. So we have a curve here, right? And we have a curve here, and we have this little slanted curve right there. Are there anywhere where it looks like the graph is pointing up towards infinity or down towards negative infinity? And the answer is yes. So where does it look like that occurs on this graph? -5 and +2? Good. So if we were to sketch in the vertical asymptotes, do you guys agree it would look something like this? And then at +2? So when we write what the vertical asymptotes are, guys, what do we write? Do we just write the numbers, or how do we write it? Good. X equals. So x equals -5, and x is equal to 2. Okay? So something that's going to come up in calculus also is using a graph or using a function, we can use limits to talk about vertical asymptotes. Okay? So this is what we use for limits. So with limits, okay, for this problem, we're only going to talk about this vertical asymptote, okay? We could also do the same thing for the other one, but just to get you guys, so you guys understand what's going on. So I'm going to write this down, then I'll explain what it means. The limit as x approaches -5, and then I want you guys to draw what looks like a little negative as like an exponent, like that. Okay? Of f of x. Okay? When we write this, like this, and same thing when you guys take calculus, when you guys see this, this means the limit as x approaches -5 from the left. Because, do you guys agree on a number line? Numbers that are to the left are smaller. Does that make sense? So if I'm looking at when x approaches -5 from the left, that means as the graph goes towards -5, so do you guys see how my arrow is going like to the right? But do you guys agree this is the left side of -5? So that's what I'm talking about. On the left side of -5, what's happening to the graph? So on the left side of this asymptote, do you guys see how the curve's pointing downwards? Okay, so what is that pointing down towards? Which number? -infinity. So the limit as x approaches -5 from the left of f of x is simply just -infinity. Okay? So what this means, so if you guys can write this in your notes, this means, you don't have to write this on your homework, but just for your notes, this means as x approaches -5 from the left, comma, f of x approaches -infinity. So minus is from the left. So logically, what if I want to talk about the right side? How would that notation change? How would this change if I want to talk about the right side? It would be positive, right? Things that are to the right, do you guys agree, are like positive on the number line? If I'm going to the right of a number, this way it's getting bigger. Does that make sense? So the limit as x approaches -5 from the right of f of x would equal positive infinity, because if this is our asymptote, on the right side of the asymptote, do you guys see how this curve is going up forever? Okay, you guys follow me? Does that make sense? So the limit as x approaches -5 from the right of f of x is equal to infinity. So as x approaches -5 from the right, f of x approaches positive infinity. Okay. Okay, is everybody good? Questions? Okay, so let's look at this problem right here. So this time, let's say that g of x is equal to x squared minus 9 all over x squared minus 4. Okay, so this one, we have a lot of work to do. What's the first thing I should try to do? Factor. So if I factor the top, this is a difference of squares, so it's going to be x plus 3, x minus 3. On the bottom, it's also a difference of squares, so I'm going to have x plus 2 times x minus 2. So now let's put everything together that we've learned so far in the last week and a half, okay? If I want to know what the zeros are, which part of the fraction do I look at? The top. First of all, did anything cancel? So that means the graph has no what? Holes, no holes. So the top of the fraction, do you guys agree that this did not cancel and this did not cancel? So that means that I have zeros where? Good. X is equal to -3 and x is equal to positive 3. Okay, so what I want you guys to do is, as you guys are kind of going through that checklist, I want you guys to plot those points. So at -3, I have a 0, and at positive 3, I have a 0. Cool? All right. Do I have any vertical asymptotes? Is there anything that makes the bottom 0? What numbers make the bottom 0? Yes, x is equal to 2 and x is equal to -2. So vertical asymptotes, guys, let's go ahead and sketch those in. So at x equals -2, we have a vertical asymptote. At x is equal to, positive 2, my bad. We have a vertical asymptote. Okay, is everybody following me? Does this make sense so far? What's something else that we could look at? So think about everything you guys have learned since your test. What's something else on the graph that we can look at the function, decide if it has or not? Good. Horizontal asymptote. So to decide if there's a horizontal asymptote, guys, what do I pay attention to? The powers. Good. Look at the original function. Highest power is 2. On the bottom, highest power is 2. So those are the same. So what do we do? Divided leading coefficients. So I have a 1 here and a 1 here. So 1 over 1 is 1. So the horizontal asymptote is going to be y is equal to 1. So let's go ahead and sketch that in. So just to get you guys ready for Friday, remember that means if there's a horizontal asymptote at 1, that means the limit as x goes to infinity is going to be 1. And the limit as x goes to negative infinity is going to be 1. Okay? All right. What else can we find that we haven't talked about yet? Domain, we could find domain. Yes. But on the graph itself, though, what else could I plot or label? The y-intercept. So what do I plug in to find the y-intercept? 0. So if I plug in 0, f of 0, or sorry, g of 0, because g, my bad. G of 0 is going to be, if I plug in a 0 on top, guys, what's going to happen to this guy? This cancels out, right? And then this will cancel out. So it's going to just be negative 9 over negative 4, which is, somebody help me out, 2.25? That's crazy. If only you guys had calculators, right? Oh my goodness. That'd be so nice. 2.25? All right. So let's go ahead and plot that. So it's going to be 0, 2.25. So something like that. All right. So here comes the hard part. We're going to use all this information now to graph this. Okay? And so what I want to do is I'm going to show you guys like the really fast kind of like sneaky way to graph this without having to make it, like last year you guys made like a big table and plotted numbers to figure it out. Okay. So we know something about limits. So if there is a vertical asymptote here, that means from the left, this graph either goes towards infinity or it goes towards negative infinity. I need to figure out which one of those it is. But do you guys see how there's already a 0 right there? That means that the graph is not going to do that. And it's also not going to do that. Does that make sense? It's either going to do something like that. And the way that we can for sure know this is by plugging in a number that is less than this number. So does it make sense that I could plug in like negative 4? Okay, if I plug in negative 4, I should have given you guys more space. If I plug in negative 4, I'm going to do this. Let's use limits. So the limit as x approaches negative 2 from the left of g of x. This is our asymptote, right? At negative 2. I want to know what's going on just this way of the function. So basically, do you guys remember the problems we did at the very beginning of Unit 1 where you guys would approximate the rate of change? So I told you guys to pick a number like really, really, really close to a number. So do you guys agree that a number that's really, really, really close to negative 2 on that side would be like negative 2.0001? So if I do negative 2.0001, let's just do that, plus 3, negative 2.01 minus 3, all over, there we go, that's what I want. Negative 2.01 plus 2, negative 2.01 minus 2. Again, you don't have to come up with a number, you just want to know what the signs are. So 3 minus 2.01, is that going to be positive or negative? Three minus 2.01, is that going to be positive or negative? Positive. Negative 2 minus 3, is that going to be positive or negative? Negative. Did I mess up? Oh. Negative 2.01 plus 2. It's negative. Negative 2.01 minus 2. So on top I have a, on bottom I have a, so that means that this goes towards. That means that because the sign is negative, that means from the left side, this graph is going to go towards negative infinity. So kind of like what I showed you guys is probably going to happen. So that means that it's going to do something like this. Okay. Okay. On the right side, that means that we're going to plug in something a little bit bigger than negative 2. So like negative 1.999. So you would say the limit, you guys have enough space in your notebook, right? Like right on the sides to do this? Okay. So I guess that's kind of a good thing. The limit as x approaches negative 2 from the right of g of x is going to be negative 1.99 plus 3 times negative 1.99 minus 3 all over negative 1.99 plus 2, negative 1.99 minus 2. So 3 minus 1.99, that's positive. Negative 1.99 minus 3, that's negative. Negative 1.99 plus 2, that's positive. Negative 1.99 minus 2, that's negative. So the top is a negative, the bottom is a negative. So that's going to be positive infinity. Okay? So that means on the right side of this asymptote, this graph is going to do that. Does that make sense? So the question becomes, though, is it going to do this or is it going to do that? Because remember what I told you guys, I lied to you. You can cross horizontal asymptotes. So here, do you guys see how this green curve does not? That doesn't mean that in the middle, it can't do something like this. So you'd have to test a number also for this asymptote, okay? So I know it's gonna do something like this. So this asymptote is positive 2. So let's plug in something. That's a little less than positive 2. So what can I plug in, guys? Huh? 1.99? Is that 2? Yeah, it's a 2. So this is going to be a positive times a negative all over a positive times a negative, which is a negative over a negative, which gives me a positive. Which means what's going to happen, guys, is this curve going to go down or shoot up? It's going to shoot up, right? So it's going to go like this. All right. Now, here comes the question. This 0, right? It's below the horizontal asymptote. Do you guys see that? So the curve is not going to do something like that. It's most likely going to stay below. Do you guys believe me? If you guys don't believe me, you guys aren't sure, you guys agree, you could also test a number that's a little bit bigger than 2 and plug it in. If you guys plugged in like 2.01 and plugged it in, you guys would see that this goes towards negative infinity. Mr. Vigil. Hey. Okay. Okay. Okay, yeah, because the same thing happened yesterday too. Okay. All right, thank you for letting me know. Okay, yeah, I knew that. I knew that. Okay. All right, thank you. All right, bye. All right. So, AP exam. You will not have to graph something like this by hand, okay? But knowing how to do this is really important in terms of like limits, because in calculus, you guys will have to understand limits really well. The whole first like 3 weeks of calculus is limits. Okay? All right. So I know that's a lot of work. Questions? Okay. So let's look at example 3. You guys keep your calculators out because we'll need our calculator for this one. So for this problem, we're just going to identify the vertical asymptotes and the behavior near the vertical asymptotes. So which part of the fraction do I look at to determine the vertical asymptote? The bottom. What makes the bottom 0, guys? 2. So this graph has a vertical asymptote at x is equal to 2. So what I want you guys to understand is if that's positive 2 on the x-axis, okay, that means that the graph, do you guys agree, has something like this going on? So the question becomes, does it do this or this? And then does it do this or this? Does that make sense? So the way that we can do this is also with a calculator by testing numbers, okay? So are these numbers bigger than 2 or smaller than 2? Smaller than 2. So that means that you guys agree that these numbers, since they're smaller than 2, would be on the left side of 2. So this would be as x approaches 2 from the left. So with our calculators, give me a second to pull it up. Not my YouTube. That's awkward. You're going to go to y equals, parentheses, what's on top? X squared. Is it plus 3x? Okay, close the parentheses, divided by, parentheses, what goes on the bottom? X minus 2. Did you charge it? It's still doing that? Okay, you're gonna have to probably go to the library and swap it out. Yeah.
Right now or?
No, not right now. Just borrow one right now. That way you don't miss. You can try it, yeah. But I just don't want you to miss. Okay, how do you look at the table? Second graph, okay? And then how do I tell the calculator what numbers I want it to pick? These are things you guys need to know how to do. Huh? But how do you get there? Like, if my calculator does this, does your calculator let you guys type in whatever? What if it got reset though? How do you get there? Not second window. Oh yeah, it is second window. Second window, and then change what? Yes, change the independent to ask. Second table. Jerry, what's the first number in the table? 1 point what? 1.9? And then it's 1.99. And 3 nines? Is it 3 nines? And then 4 nines? Okay. Okay. So from the left side of 2, ignoring the negative for now, guys, are these numbers getting bigger or smaller? Ignoring the negative. They're getting bigger, right? But they're also negative, right? So if they're getting bigger and they're negative, 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 this is going to go towards negative infinity. Does that make sense? Because that's a huge number. If you guys were to graph that, do you guys agree you guys would need a lot of graph paper? Because that would be way low on the y-axis, okay? So negative 93.1, negative 993, negative 9,993, and then negative 99,993. So what can we say? The limit as what? X approaches what? Just 2? What side of 2 are we doing right now? From the left. So do I put a minus or a plus? Minus. What's my function? G of x is equal to negative infinity. Good. All right. Now, do you guys agree for the other side? I'm just going to do the same thing, but just type in the numbers. Okay, so just save us time. I'll just tell you guys what they are. So this is as x approaches to, I don't like my arrow. From the right. So at 2.1, we have 107.1. At 2.01, calculator says 1,007. And then 10,007. And then 100,007. So there's a pattern. What is this going to eventually go towards? Infinity. So the limit as x approaches 2 plus of g of x is equal to infinity. Okay? Now, for this, is there a horizontal asymptote? Thank you. No. Why? The top is bigger, right? So that means that the limit as x goes to infinity is either going to be infinity or negative infinity. because that's what that means. And the limit as x goes to negative infinity is either going to be infinity or negative infinity, okay? This graph actually has what's called a slant asymptote. So it actually has something like that. You guys will learn that after your quiz next week, how to calculate those. And do you guys know what we have to do to find those? Long division. So we're gonna bring back long division and synthetic division next week. But every year, I know you guys moan and groan because I've done my first year teaching pre-calc. Every year the kid's like, oh, that was hard. I hated doing that. You guys will get really good at it. Trust me. When I give a long division question on a pre-calc test, almost all the kids get it right because it's like the second year they've learned it, so they get good at it. Okay, you guys will be okay. All right, last question. Yeah. Tissues? They're on my desk. H of x is equal to x squared plus 4x minus 12 all over x minus 2 squared. Thanks, you too. See you Friday. Okay, what's the very first thing I should try to do, guys? Factor. So on the bottom, do you guys see how it's already x minus 2 squared, so there's nothing I can do with that? But does a top factor? Yes. What is a factor to, guys? X minus 2, x plus 6? Does anything cancel? Yes, good. One of the x minus 2's on the bottom cancels with the x minus 2 on top. So this is gone. This will just become just first power. So I'm left with what? X plus 6 all over x minus 2. So this is the function that we're paying attention to. Okay? All right. Domain. For the domain, you only care about the bottom. What makes the bottom 0? Positive 2. So do you guys see how this canceled? If this was like x minus 2 times x plus 5 and it canceled, you would still have to include that as part of your domain, okay? But because 2 is the only thing that makes the bottom 0 here and here, that's the only number we have to worry about. So the domain is going to be all real numbers except 2. So negative infinity to positive 2, union 2 to infinity. Okay, this one's tricky. What have you guys always learned about holes? A hole occurs when what happens? When something cancels. Okay, what was the thing that canceled? X minus 2. But what's left on the bottom still? X minus 2. So you guys agreed to find the hole, I would have to plug in 2. But can I plug in 2 into the bottom? So the hole would be at 2. But because I still can't plug in 2, that means there is no hole. Does that make sense? So you guys can either say does not exist or none. Okay. Zeros. Which part of the fraction do I look at to find the zeros? The top. What makes the top 0? Negative 6? Is that what you said? Oh, I thought you said 6. Okay, so x is equal to negative 6. I'm deaf. Sorry. It's too much loud music. All right. Vertical asymptotes. Which part of the fraction do I look at for vertical asymptotes? The bottom. What makes the bottom 0? 2. So x is equal to 2. Okay. All right, so let's pretend like you guys don't have a calculator for this question, because you could use a calculator in a table like we just did, but what if you can't have a calculator for this question? So for a limit notation, do you guys agree the graph at 2 is going to look something like that, right? So I need to figure out, is it like this or this? And then is it like this or like this around the asymptote? So the limit as x approaches 2 from the left of, what is it, h of x? Yeah. Is equal to. What I'm going to do is, on the left side of 2, so I'm going to plug in something really small, or just small of 2, so like 1.99. So plug in 1.99 into the top, 1.99 into the bottom, and see what happens. So we have 1.99 plus 6 divided by 1.99 minus 2. 1.99 plus 6, guys, is that positive or negative? Positive. On the bottom? Negative. So positive divided by negative gives me a negative. So that means that this goes towards negative infinity. Good. Okay. Now here comes the cool part. Actually, I don't want to show you guys that yet. I don't want to confuse you guys. X approaches 2 plus. So plug in something a little bit bigger than 2. So like 2.01. So 2.01 plus 6 divided by 2.01 minus 2. 2.01 plus 6 is positive. 2.01 minus 2, that's still positive. So this goes towards negative? Oh, positive infinity, yeah. So how would you guys describe these answers, guys? Are these the same or different? Different. You guys want something cool? If this right here is squared, whatever you get for this answer will be the same for that answer. Always. It's a little cool little shortcut. I still, at this level, because you guys are like rookies at this, you guys are learning this, I still would test numbers until you guys see that pattern, okay? All right. Horizontal asymptote. You can either look at the beginning or you guys look at the simplified version. I'm going to look at the simplified version. What do you guys notice about the powers? They're the same, so we divide leading coefficient, so what is it? 1. And lastly, y-intercept. What do I plug in? 0. So h of 0 is equal to 0 plus 6 divided by 0 minus 2. So 6 over negative 2 gives me negative 3.